Okay, Assalamualaikum and a very good day to all. So we are going to continue to chapter 3, which is kinematics on one dimension. Okay, the things that you need to understand here, we are going to investigate a field we call as a mechanics. A mechanics can be divided into two, which is kinematic and also dynamics. Okay, so when it comes to the kinematic, it's about how object move, and dynamics, it deals with force and why object move as they do. Okay, so now we are going to discuss translational motion, which means that the object that move without rotating. Okay, so means that now we are going to discuss or describe the object that move in one straight line path. Okay, so object that rotating we call as the rotational motion. That one going to be discussed in the next chapter. Okay, now we are going to focus only for the translational motion. Let's proceed. Okay, so before we go further with the calculations, definitely you need to have a good understanding about what is distance, what is displacement. Okay, so we are going to start with that one first. Okay, so based on your understanding before, distance is a scalar and displacement is a vector. Okay, the difference between these two is displacement is basically how far the object is moving. How far is the object moving from its starting point? Okay, regardless of how it got there, means that you only focus on the initial and final only. Okay, you focus only on initial and you focus only on the final. Okay, that's why when you got the formula is going to be delta S, which means that the change of position equals to S final minus S initial. Okay, and then for the distance is measured along the actual path. It means that the total distance travel, okay, means that if you move to, like example, you go to the Mid Valley and after that you go to the Ole Ole and after that you go to the Intake. So how much total distance that you have traveled, that is going to be distance. Okay, so distance is scalar, which means that you only consider about the magnitude, and for displacement you need to consider also magnitude and direction. Okay, so in front of you can actually see that the displacement is basically written like this. Okay, so from the first picture you can actually see that the first position is at 10 and then it's moving to this second position. So the displacement for this one going to be change of S or delta S, which means that 30 minus 10, which means that it's going to move 20 meter, and that is going to be displacement. Okay, that's why you need to consider the direction, because you have displacement positive and displacement negative. If example is moving from 30 meter here, is moving to 10, so you are going to get here is final minus initial is going to be 10 minus 30, you get negative 20. Negative 20 there represent is moving to the left. Okay, when you get negative, you need to state what does it mean by that negative. Means that it's moving 20 meter to the left. Okay, before this we discussed about distance and displacement. Now we are going to discuss about speed and velocity. So as you can see that we have speed, we have average speed, we have average velocity, we have instantaneous velocity. But basically when you state about speed, you are also state about instantaneous velocity. This one I'm going to discuss later. Okay, but now I want to state that about the average speed. Average speed is basically the total distance that you have traveled divided by the total time that you need to take to travel in that particular distance. Means that you need to add up every single thing for your distance, and then you need to add up all the time, then you get the average speed because it's scalar. Okay, Okay, now we talk about velocity. So basically velocity is a vector, and velocity is used to signify both the magnitude and of how fast an object moving, and also the direction in which it's moving. Okay, so we have velocity, we have average velocity. When you talk about velocity, basically we talk about instantaneous velocity, which I'm going to cover it later. Okay, average velocity is basically you need to calculate the displacement divided by the time take to travel to this point. So means that your formula going to be v bar. Bar here represent average velocity. Okay, so v bar is basically the change of position divided by the change of time, or we can call as a time interval. Okay, so when you state velocity is going to be instantaneous velocity. When you want to say about the average velocity, means that you need to have word average there. Okay. Okay, so this is basically the formula that I have mentioned before. Please make sure that you don't use d. D is basically can give you a different meaning, because right now we are going to discuss only in one path s, so it's better you change into s. This one change into s. Okay, much better. Okay, so now in front of you we are going to calculate the average speed and average velocity. Please take note, when it comes to the speed, is about total distance taken, and average velocity is about displacement. Okay, so when it comes to average speed, means that you need to add up all the distance that this person takes. So means that it's moving 70 meter and then it turns around 30 meters, so the total going to be 100 meter. Okay, the time taken to complete this task is 70 seconds. That's why you are going to get answer 1.4 meter per second. Okay, but when it comes to the average velocity, what happened in the midway, you don't have to care about it. Okay, you only focus on the initial and final only. So means that it's moving 70 meter to the right, and then it's moving 30 meter to the left. So means that the average velocity is going to the displacement going to be calculated from how far from the initial point. So it's going to be here is going to be 0 final minus initial. It will be 40 minus 0. So that's why you're going to get 40 meter over there. Okay, so for the average velocity, if you get positive, it means that it's moving along the positive x-axis. If you get negative, it moves in the negative x-axis. Please take note, the directions of the average velocity always follow the directions of the displacement. If your displacement is negative, definitely you are going to get your average velocity negative. Okay, so this is basically a very simple questions where the questions ask you to find the runner average velocity. The runner changed position from s1 50 meter into s2 30.5 meter in 3-second time interval. So v bar going to be the s final going to be 30.5 minus 50, then divided by the 3 second. Then you are going to get your answer is negative 6.5 meter per second. Negative here means that the runner moving to the left. Okay, when you have a negative answer there, please state what does it mean by the negative. Okay. Next question, how far can a cyclist travel in 2.5 hours along a straight road if her average velocity is 18 km per hour? So right now the question already give you the average velocity, and then they already give you the time, but now they are going to ask you how far. Means that the displacement, so from the formula, average velocity equals to change of position divided by the change of time. So right now we were going to find the change of position. So 18 km per hour multiplied by 2.5 hour. So you are going to get 45 kilometer. Okay, very simple, right? Okay, so now we are going to talk about instantaneous velocity. Okay, instantaneous velocity is the average velocity in the limit as the time become infinitesimally short. Okay, very short. Okay, very short. Or we can actually say that instantaneous velocity is basically velocity at that particular time. Okay, at that particular time. Okay, so example, if you need to find the velocity at position of 2 meter, what is the velocity at 2 meter, at a particular 2 meter? Maybe it's going to be 20 meter per second. That's what we call as the instantaneous velocity. Okay, so the notation of limit t approaching 0, we are not considering it as a 0 because we are going to get undefined number. So though we are going to put as a ratio of change of x divided by the change of time as whole. So we let t approaching 0 means that we let x approaching 0. Okay, so as the limit approaching, as the t approaching 0 in the calculus notation is going to be the derivative of x with respect to time. Okay, so that's why this one we cannot consider as totally 0. If not, we are going to get undefined number. Okay, so we put it as a whole. Okay, both are approaching 0 at that particular time. Okay, so there's a certain conditions where your instantaneous velocity will be equal to your average velocity, where you have a constant velocity. Okay, when you have a constant velocity, your instantaneous velocity will be equal to your average velocity, which means that you can actually see that instantaneous velocity will be equal to your instantaneous speed. That's why we didn't discuss a lot about instantaneous speed, because it's going to be the same concept as instantaneous velocity. Okay, but this one only apply for constant velocity. But it's not happen all the time. It's not happen all the time where in front of you can see that the average the velocity keep changing. Okay, so it means that at one particular point, basically you can actually see that it's keep changing. So we cannot say that the instantaneous velocity equals to average velocity. Okay, so to better understand the instantaneous velocity, let us consider a graph also. Okay, so you can actually see that okay, you have P1 here and then you have P2 here. So we can actually see that when you connect from P1 to P2, you are going to have one slope here. Okay, you are going to have one slope. Okay, but okay, this slope basically represent the average velocity. Why? Because you can see that this is the change of position and this is the change of time. So means that the slope here represent average velocity. Okay, so what if we put one point here, we call it as a pi. Okay, so the average velocity for the pi and the p1 will be less than the p1 and p2, right? Because the slope is less than the p1 and p2. Okay, but what if we take point pi to be closer and closer to the p1? What will happen? Okay, so what happened when the pi approaching p? You can actually see that from the animation in front of you. When the pi approaching p, the slope of average velocity are going to be the slope of instantaneous velocity at the particular p. Okay, so you can actually see that. Okay, so when the q, or we can see at the pi approaching p, then it's going to be slope of instantaneous velocity. Okay, so the instantaneous velocity is basically a property of the object at one single time, at that particular time, and the average velocity is basically the object that depends on two times. Okay, got it? Okay, good. Okay, point. So as you can see that there's a graph in front of you. Okay, and the slope basically represent there is an instantaneous velocity. So you can actually see that from the P1 to the P2, slope at the P1, slope at the P2 more steep in compare with the P1, which we can say that the slope which we can say that the velocity is increasing. Okay, so velocity increasing. Okay, however, when this object approaching P3, what happened is the slope begins to decrease, which means that at this particular point the velocity going to be 0. Okay, and then when it reached to the point P4, the velocity is therefore negative. Okay, because the slope is negative. Okay, slope is negative here, which makes sense since x is now decreasing. Okay, x is now decreasing. That's the reason why you got your slope negative and your velocity negative. Okay, so the particle is moving toward, as you can see that from the graph itself, the particle is moving toward decreasing value of x. Okay, so is there any constant velocity? Is there any part that shows constant velocity here? Definitely no. Okay, so you can see that there's no part in this graph shows the constant velocity, because when you say constant velocity means that you assume that instantaneous velocity will be equal to the average velocity. Okay, okay, so in front of you there's a questions. Okay, so let's do it together. Okay, so the question asks you to find displacement. So when you have these equations, the first thing first, when you have these questions, you need to find the displacement x at 3 seconds and displacement x at 5 seconds. So when you find the displacement x at 3 seconds, so your a is 2.10, t square is 3 square plus b is 2.80. So you are going to get here is you are going to get the value is you're going to get 21.7 meter. Okay, and then you repeat the same thing for the S5. Okay, so the S5, you put it inside the equations, then you are going to get 2.105 square plus 2.80. So the answer is going to be 55.3 meter. Okay, so the question asks you to find displacement, so it means that it's going to be the change of s as final minus s initial, which means that the s5 minus the s3 second. So you are going to get here is 55 minus 25.7. You are going to get here, the answer is 33.6 meter. Okay, very simple, right? And then the question asks you to find the average velocity. So what does it mean by average velocity? Average velocity is basically, yes, the change of s divided by the change of time. You already find the change of s here. So it means that 33.6 over change of time going to be 5 minus 3. So you are going to get 16.8 meter per second. Okay. And the last one, determine the magnitude of the instantaneous velocity. The question asks you to find the velocity at that particular time. Okay, so when the question asks you to find the instantaneous velocity, okay, what you need to do here is, okay, here is you need to, okay, you need to differentiate first the s equals to at squared plus b. Okay, because like I mentioned before, the ds over dt is basically the instantaneous velocity. So you have average velocity, which is ds over dt. So here you are going to differentiate the ds over dt here, which is a is 2.10 t square plus 2.80. So you are going to get here is, okay, I'm going to continue to this side. Okay, sorry. Okay, so you're going to get here is so you're going to get here is 280, which is 2.10, and t you are going to get 5. So the answer is what? So answer is 221.0 meter per second, like that. Okay, so please take note when it comes to instantaneous velocity, please take a look at the questions. If you have equations over there, that means that you need to differentiate. Okay, let's move forward with the next one. Okay, I already show it at the working step here. Okay, you can actually refer to that also. Okay, next we are going for the acceleration. Same goes like a speed and also velocity. Acceleration also have an average acceleration and instantaneous acceleration. So when we said about velocity, we said about change of position. But when it comes to acceleration, we said about change of velocity, rate of change of velocity. So the formula going to be average acceleration with the a bar over there, change of velocity divided by the change of time, and the unit is meter per second square. So means that when you have 5 meter per second square, it means that the velocity will be increased 5 meter per second for each 1 second. That's meant by acceleration. When you see there's a change of velocity, definitely there will be an acceleration. Okay, so what is the magnitude of each average acceleration? Same goes like average velocity. You don't have to take care about what happens in the middle. You only take care about what happens at the end and initial point only. Okay, so means that your average acceleration is going to be average acceleration is change of velocity divided by the change of time. So means that 25 divided by 5, so you are going to get 5 meter per second square. Okay, very easy, right? Okay, so the next questions. Okay, what was the car average accelerations? Right now the car is moving from velocity of 15 meter per second into 5 meter per second, which means that there's a change in terms of velocity. When there's a change in terms of velocity, definitely there will be an acceleration. But this one, we state about deceleration. Okay, please take note, deceleration and negative acceleration is totally different thing. Okay, deceleration and negative acceleration is basically different. Okay, when you state about negative acceleration, okay, when you state about negative acceleration, it means that you still accelerate. Okay, accelerate, which means that you still have increase of velocity. Okay, velocity, but you moving in the negative direction. Okay, you still accelerate, you still have increase in terms of velocity, but you're moving in the negative direction. Or here we put that negative to the left, so it means that you move to the left. Okay, but when you state about deceleration, it means that slow down. When you slow down, it means that you have a decreasing of velocity. Okay, so it's basically two different terms. Okay, give you two different meanings. So please do not confuse that the negative acceleration is basically deceleration. No, deceleration is totally different thing. Negative acceleration is totally different thing. Okay, and then you need to understand that deceleration is not always be negative. Okay, by example, if the question didn't state anything, then you can actually put the negative there. But there's times where your deceleration can be positive. Okay, yes, it can be positive. Where example, you have one car here moving to the left. Okay, decelerate and moving to the left, moving with negative 15 meter per second, and then it slow down, moving to the left also, and it slow down. -5 meter per second. So when you put it inside the calculations for the average acceleration, you are going to get -5 minus 15 divided by time taken. Example, time taken is 5 seconds. So you're going to get positive deceleration. Okay, so that's why I state that deceleration is not always be negative. It can be positive, it can be negative, but if the question didn't state anything, then you just put it as a negative. Okay, if the question want to state about positive deceleration, maybe the question is going to be going to state the situations like I mentioned before, like this. Okay, so please take note, when it comes to deceleration also, the things that you need to understand here, when it comes to deceleration, your velocity, directions of velocity and directions of acceleration always moving in the opposite. Means that if your V here, your acceleration going to be here, okay, because it slows down. Okay, when it comes to deceleration, your velocity and acceleration will be moving in the opposite direction. Okay, so basically in front of you, when the question asks you to find the average acceleration, and basically we can see that there's a decreasing in terms of velocity, this situation is going to be decelerate. So this one basically very easy, where you just put it as a average acceleration is 5 minus 15 is moving in 5 seconds, so you are going to get -2 meter per second square. So negative here represent decelerate, it's not represent negative acceleration. Okay, because why? You can see from the situations of the velocity. Okay, I already explained here every single thing. Okay, so I already mentioned that there's a difference between negative acceleration and deceleration. Okay, acceleration is basically you still increasing the velocity but moving in the negative directions. Decelerate basically is about you slow down, and your acceleration and velocity moving in the opposite direction. Okay, so this one can be positive, it can be negative. Okay, same goes like velocity. We are instantaneous velocity, we also have instantaneous acceleration. Okay, so instantaneous acceleration is basically the average acceleration in the limit as the time interval become very, very short, infinitesimally, very, very short. So means that in the easiest word, acceleration is basically the acceleration at that particular time. Yes, okay, at that particular time. Okay, so you can actually say that the acceleration also, the average acceleration when t approaching 0 is basically the derivative of v with respect to t. So means that when you have instantaneous acceleration, you need to differentiate twice, differentiate 2 times. If questions give you if the equations stay in x, which is the position, so it means that you need to differentiate this one 2 times, then you are going to get dv over dt. Okay, because if you differentiate 1 time, you are going to get velocity. If you differentiate 2 times, you are going to get acceleration. Okay, instantaneous acceleration and instantaneous velocity. When you state about acceleration, it means instantaneous acceleration. When you want to say it about average acceleration, then you need to put words average over there. Okay, so like this one, velocity is basically the rate at which the displacement changes with time. Okay, and we can actually say that the change of position. The acceleration is basically the rate at which the velocity changes with time. Okay, so acceleration is rate of rate, which means that you need to differentiate 2 times. Okay, so this one also, this one is pretty easy questions. Okay, you don't have, okay, you are going, the questions show you the graph just to which mean but it doesn't but you don't have to care about it. Okay, from the question itself you can actually answer without looking at the graph. Okay, so right now the question asks you to find the average acceleration. When you average acceleration, it means that you need to find two velocity, which is the velocity at 3 seconds and at 5 seconds. Okay, so how to solve this question? Okay, first thing first, the question give you x. Okay, so for you to find average acceleration, you need to use v. So you need to differentiate. Yes, one time for you to find the equation for v. Okay, so it become, so this is the origin 1, 2.10 t square plus 2.80. Sorry. Wait. Okay, plus 2.80. Okay, so differentiate one time for you to find the velocity. You are going to get 4.20 t. Right. Okay, so this is basically a velocity. So the question asks you to find the average velocity. So it means that you need to find the velocity at v3 second. So you just put 3 seconds into this formula. So you are going to get 4.203 like that. Okay, so means that 4.203, you are going to get, the answer is 12.6 meter per second. Okay, and then you need to find the v at 5 seconds, which is 4.205 seconds. Okay, so you are going to get here is 21.0 meter per second. Okay, and then the question asks you to find the average velocity, which means that you need to put it inside the formula, which is v final minus v initial, v5 minus v3 over t5 minus t3. So 21.0 minus 12.6 over 5 minus 3. So you are going to get 4.20 meter per second square. Okay, that's how you do it. Okay, easy, right? Okay, so now the question asks you to find the instantaneous acceleration as a function of time. So when it comes to instantaneous, like I mentioned before, you need to differentiate. Yes, good. You need to differentiate 2 times. Okay, you need to differentiate 2 times. So means that here you already have this one when you differentiate 1 time. So you differentiate 2 times for you to find the instantaneous. So means that it's going to become 4.20 meter per second square. What does it mean by this? What does it mean by instantaneous? You get 4.20. But average acceleration also you get 4.20. What does it mean? Yes, it means that these two represent constant acceleration. Okay, and you can actually see that clearly enough in the graph. Constant acceleration. Okay, understand? Okay, good. Okay, I already showed you all the equations at the back. You can actually refer to that also. Okay. Okay, so now we are going to analyzing the graph. Okay, this one you just analyzing the graph, which is practically very easy. Okay, this figure shows the velocity as a function of time for 2 cars accelerating from 0 to 110 km per hour in a time of 10 seconds. Compare the average acceleration. So the answer is going to be yes, good. Car A and car B have the same average acceleration. Why? Because it starts at the same point, it's finished at the same point. That's why for the average acceleration, both car A and car B have the same average acceleration. Okay, what about instantaneous acceleration? Okay, instantaneous acceleration, it depends on where is the time that you need to look at. Okay, if I want you to compare at 4 seconds. Okay, so now we are going to depends on the slope of the graph. Which one is steeper, car A or car B? Okay, so at 4 seconds, definitely at 4 seconds, is steeper than the car B. Therefore, car A has greater acceleration at 4 seconds. Okay, but what about at 8 seconds? No, okay, actually see 6 seconds. Which one is steeper? Okay, this one. I think car B is steeper than car A. So car B has larger acceleration in compare with the car A. Please take note the slope at the particular time represent instantaneous acceleration. Okay? Okay. So total distance travel for the two car. Total distance travel for the two car, it depends on what? It depends on, yes, area under the graph. So which one have larger area under the graph? Definitely is going to be car A. Okay, yes. Okay, very easy, right? Okay, good. Okay, so that's all for now. Okay, we are going to continue the next one in the next video. Okay, okay, thank you very much. Bye bye.